Hello everyone, I'm Xiaogan. Okay, we cut out some parts here, like creating the map and creating motion nectar. Okay, we'll place the first actor here. Okay, let's just get started. Then we'll do this operation inside the BeginPlay. Why not do it in the constructor? Because there would be some issues. Because it might not set up this timer at the right time. So we must put it inside the BeginPlay. First of all, obviously, we need to get this. GetWorld timer, GetTimerManager. Okay, this function here, you can see it's in our functions inside vector. We can switch. You see, get this, the instance of the time manager from this world. Actually, it is GetWorld. Note that GetWorld does not check for null. This place can actually be null. Then through this thing inside the world to GetTimer, and then this place. That's it. So this function is overload gaming instance. Actually, it is through this gaming instance. See how you get this gaming instance. If you get this gaming instance, he then goes here to get this GetTimerManager. You see right here, you can see it here, and then it's under gaming instance. There is a time manager here. You see we have a pointer on this left side. With this pointer, you can see this is a global time manager. Here we define a struct. That is, this thing should not be copyable. Yes, it's basically, it just defines a template of a standard C++ class. It's missing some methods. Okay, this is our specific time manager. The specific SetTimer is right here, and you can see there are some bound delegate T functions here. Dynamic, and there are some methods that can be called. Specifically, we actually need to drag the place to talk about it. Okay, here we actually get our world timer. Actually, for the connection here, we use this to connect. Okay, for the connection here, we call it the TimerManager. The place is mainly written out so that everyone can be clearer. Then through it, we call the SetTimer method. You can see set. Obviously, this is a reference. So you need to use this pointer to call it. You can see these two methods. Look at these four methods. There is a pass. This is, of course, pause. And this is set. And this is setLex. Let's first look at setLex. Zoom in a bit. You can see there are some things here. There are some functions here. You will find that it will pass some things here. These are some delegates. This timer dynamic is just some delegates. This one is bound to an OObject, and this one directly passes a T function. Okay, so here we will still use this one. Okay, you can see that here actually. Click in, we click. It directly returns such a timer. Handle, it is actually not filled. So the documentation comment says it does not take it as a parameter to fill. Okay, here we have cell timer. We can click this cell timer. Let's take a look. And then there are many parameters here. These parameters are actually the same as our blueprint. So we will ignore them. Note that we need a handle here. Actually, this handle might need to be received like this. Here we need to declare a handle. So we will definitely make this handle protected. The name is my hammer handle. This way we have a timer. Then let me show you this timer. This is a struct. Actually, it has a handle here. You can see this handle is a UN64, and it explains to you. This thing is specifically used for identifying this timer, and there are some constructors here. How do they complete the use of this handle? Right. Okay. And here we put this handle into it. Then let's make sure to change this part. For this function, we can just keep this name. Actually, for this function signature, We should be able to do without one party's trust. We can try it. If not needed, we can take a look. Okay, now let's create a simple implementation of it. Here it actually makes a call. These corresponding parameters are not here yet, so this handle is right here. Then here, we can click on this parameter again, and now we are corresponding to it. This means this is a light2 function, that is, using this native function method to, if it has already been set. This chapter might say you have the same handle. It might replace or substitute it. Then these parameters, the first one is the specific value, then it's who, which object is this, specifically which object, then bind this object. This method of the function, and because you might remove the actor's own information, because this timer might display my current health value. Then the method for displaying health value. Everyone uses the same method, but this method, the context of the access is different, because it's possible that this object of mine has a health value of 100, while another object has a health value of 50. Now each of these objects will have a timer. Every second it displays its current health value. So obviously the context is different. Therefore, this specifies an object. This is the specific location that a function method points to, and this is the corresponding read, whether to loop and the initial delay time. You can also find some comments here. If you pass in this interval read and time, and it is less than 0, then this function is equivalent to clearing. This is whether to maintain the loop. If not maintained, it triggers once. But first, delay, that is, before the timer for this loop is triggered for the first time, then it needs to do a certain amount of time. Yes. So actually this should be after 2 seconds, then trigger this timer. And then trigger it once every second interval. That should be it. Then here we might need a for int. We can declare it here. We give it an int sensor. Its name is the time. We just meaning each timer can only be triggered once, but each actor can trigger it, rather than triggering it once. That is, it can trigger this. This way it actually looks a bit ugly. First, subtract once. Then after subtracting, if it is less than or equal to 0, it will not trigger. So actually on this side, 3 will trigger, 2 will trigger, 1 will trigger, right? I think writing it this way doesn't seem quite reasonable. Writing it this way is really hard to read, so it should be handled this way instead. Swap the way it's written, but it's too hard to read. This kind of simplified writing, it's very simple. Just when its count is less than 0, it will no longer trigger. Then it will execute the trigger. So obviously, now it is not less than 0. We just make it transform into a simplified version. Okay, then when it is less than 0, we immediately clear this camera. Like this. And this part is the work. So obviously 3 will trigger, 2 will trigger, 1 will trigger. Then 0 will not trigger, which means we only trigger 3 times. Then when we come in for the 4th time, this place will end. For convenience, let's just print a log here. Okay. We should cover this log soon, probably in the next chapter or 2. Okay, here we'll give it a timer. Okay, here, let's try it out. Timer working. Okay, we can trigger it to give a number. We call it remand. We should call it remand. As for the number of times, remand number, we give it a d, and here we pass this number in. Prove that it can still trigger twice. The first time it triggers. Okay, our timer is actually finished executing. Yes. we can simply take a look at the effect of this execution. Obviously, we made a mistake here. You will find that it won't start up, because in this place, it needs to return a reference. And here, obviously, it indicates that this place is empty. So why did we make this mistake? Because we kept telling everyone, don't 偷字 inside the constructor. Because when the engine initializes, there is a CDO initialization process. So you need to do it inside BeginPlay. So the correct place should be here. Okay, I made a very obvious mistake for everyone. Alright, after we start here, we already have a timer's level here. At this point, we just need to drag an instance object into this area. Then pay attention to our log. You'll notice it's not there yet. Hey, 2 seconds, 1 second, 0. Okay, execution complete. Right? Then we can check why this -1 was printed. Obviously, it's because of this place. This place. Because when it comes in as 0, it will execute once more. So the slow re-execution means it won't execute again next time. Actually, this place is also easy to understand. Then understand this place. 321. Then the last time. Right.